Hello! So if you remember in the last video we were talking about a fundamental idea of where all this calculus came from. And the point was we just took 2 points and we looked at the distance between those 2 points. And if we made those 2 points closer and closer and closer until they were infinitesimally close together, then they basically would just be considered as 1 point. In other words, if we made that distance any smaller, they would be. The distance between them would be 0 and they would just be considered as that point. So that was the fundamental idea of what calculus actually was. In this video, we're actually going to put that into practice to find the gradient of a curve. So here I've drawn some curve on a set of coordinates, and I essentially want to find out what the gradient of that curve is. So let's suppose this curve is y being some function of x. Okay, it could be y equals x squared, y equals 1 over x, y equals anything, okay, any polynomial. Okay, so now what I'm going to do is I'm going to select some point x. Okay, I don't care what that point is, I'm just going to select that point. And fairly obviously, it's also going to have a y value. So I go up, I hit the curve, I then go across, and that's going to give me my y value at that particular point. Okay, so if my x value is x, then my y value is given by f of x. So in other words, I put my x value into here, and I get my y value out. So that's going to be f of x. Okay, then what I'm going to do is I'm going to move some distance to the right, and I'm going to call that distance h. Okay, so in other words, if I was at x originally and I moved to the right by h, then what is my new point? We happy it's just going to be x plus h. Okay, it could be 3, and then I move 0.1 to the right, then I'll be at 3.01. Or I could have been at 7, and I move 0.001 to the right, then I'll be at 7.001. Okay, I'm just talking generally now. So I'm at x plus h, and then I'm also going to have a y value. Can you think what that y value is also going to be? Well, if my x value is now x plus h, I put my x plus h value in terms, in for x in my function. So my y value is f of x plus h. Okay? So now what I just need to do is I need to find the gradient. I've got 2 points, so I can find the gradient between those 2 points. Okay, so my gradient, which is given by m, okay, that's change in y over change in x. I'm going to drop the m now just so I don't have too many letters flying around. So change in y divided by change in x. Okay, so what is my change in y? Well, my change in y is just going to be given by this distance here. That is my change in y. So what is that distance? Well, it's f of x plus h minus f of x. Are you happy? It's going to be the difference between those 2 points there. Okay, if this point was say 10, and this point was say 7, then in order to get the difference between them, it's 3 because I got 10 minus 7, which equals 3. Okay, it's just f of x plus h minus f of x. Okay, what's my change in x? Well, I've already just defined my change in x. My change in x is just given by h. Okay, it's literally well defined. You could have done it by x plus h minus x, so the x is just cancelled and you're just left with h. But that is just simply my change in x. So is that my gradient of my curve? Is that what it's given by? Well, not really, because remember the fundamental idea of calculus is that I'm making the distance between my 2 points. So here's my first point, here's my second point. I'm making that distance smaller and smaller and smaller. Well, what is that distance? It's h, right? That distance is h. So in other words, I need to make h become nothing. Well, that idea is called a limit. And if you think about a speed limit, okay, a car starts from 0 and then it accelerates up towards that limit, and it mustn't exceed that limit. Okay, it mustn't exceed that speed limit. So this is exactly the same concept in maths. We've got the distance between those 2 points getting smaller and smaller and smaller. In fact, they're infinitesimally close, and we call that idea a limit. Okay, so we write that, we're making that distance between the 2 points, which remember is h, we're making that approach 0. So we write that idea as the limit as h approaches 0. So in other words, I'm going to rewrite this thing now as the same thing again, just with the limit as h approaches 0. I need to tell whoever's reading this formula that I need to make h as small and small as possible, as smaller and smaller and small as possible until it's infinitesimally close together. Okay, so that whole idea is summed up in there. Now, is that equal to change in y over change in x? Well, kind of, because change is given by the symbol delta, and that's a capital delta. That's a big change, right? A small change is given by the small letter delta. Okay, that's a small change. But I'm talking about a change which is infinitesimally small. And so I've run out of deltas now, so I'm just going to use my d from my English language, right? And so we say this is dy divided by dx. This is big change, this is small change, and this is change which is so infinitesimally small that it's basically 0. Okay, so it's dy by dx is equal to the limit of my function, with x plus whatever my tiny distance is, minus my function over my tiny distance. And I need to make that distance as small as possible. And this is something called first principles.